The Earth's atmosphere is made up of different layers containing progressively fewer atoms of gases with height above the Earth. From a height of about 50 kilometers up to 400 kilometers, the atmosphere is also designated as the ionosphere, because ionization takes place there. It is divided into 3 layers: D, E, and F. Ionization is the process by which negatively charged electrons are dislodged from the outer shells of an atom by ultraviolet light from the sun, leaving the atom with an imbalance of positive ions. When gas is in this state, it is known as plasma. The extent of the ionization is such as to create bands of negatively charged electrons, and it is these bands, or layers, which refract radio waves. Ultraviolet light waves of different frequencies penetrate the atmosphere to a different extent, creating bands of ionized gases at different levels. Because ionization is dependent upon the sun's energy, it is greater during the day than at night. There are 3 distinct layers in the ionosphere, called D, E, and F. Layer F divides into 2 layers during the day, called F1 and F2, but they recombine at night. Layer D is found at an average height of 75 kilometers in the atmosphere. Ionization is low, because it is the lowest region of the atmosphere to be ionized. It has the limited ability to refract signals of low frequencies, but the waves of most frequencies are attenuated or pass through it. At night, the negative electrons and the positive ions recombine, and the D layer disappears until the next sunrise. The E layer, also known as the Kennelly Heaviside layer, after its discoverers, is found at an average height of 125 kilometers. Normally, the layer can only reflect waves having a frequency lower than about 10 MHz, and it has a negative effect on wavelengths above 10 MHz due to its partial absorption of these waves. At night, the electrons and ions begin to recombine, doing so more quickly at lower levels where the sun's radiation is lost first. Consequently, the E layer is effective at a greater height for a while at night, and is able to refract waves further than during the day. The F layer, also known as the Appleton layer, exists at an average height of 225 kilometers. During the day, the layer divides into 2, known as F1 and F2, because the different frequencies of radiation from the sun ionize the gases to a different extent. At night, there is only one F layer, which is narrower than the combined width of the daytime layers. The ionization in the F layers is quite intense. Consequently, these layers are responsible for most skywave propagation of radio waves, facilitating high-frequency radio communications over long distances. This frequency band is commonly known as shortwave, and lies between 3 and 30 MHz. During the summer, as the sun shines more directly on the Earth, the F2 layer is higher, and so radio waves will be refracted further.